Hey, how's everybody doing? My name is Matthew Barrie. I'm doing a 6-minute talk, or a 6-minute thermodynamic talk on heat exchangers. Here's an overview. So first of all, we're going to talk about a heat exchanger. What is that? What the heck is that? Next, we're going to go over the governing thermodynamic equations. And then after that, we're going to go through just some various applications in day-to-day life in which a heat exchanger is implemented, and you'll be pretty surprised at that. First, what is a heat exchanger? A definition that I kind of brought up, and I just didn't want to use a plain definition, copy and paste, but I said it's a vehicle by which heat is transferred from one substance to another. A good example of this is a shell and tube heat exchanger, in which you have a tube going through the obvious exterior shell, and there are two fluids which are independent of each other. Whether you want to transfer heat to or from the center pipe, that's really dependent on what process you're working with. In this case, it's warm fluid in, and then the warm fluid goes out of the pipe because the heat is transferred to it. Next, thermodynamic principles. Using the first law of thermodynamics, we can do an energy balance to solve for heat transfer. So we just do our typical first law energy balance, but we can see that our work goes out, and we can get that our heat transfer is equal to our mass flow rate times our enthalpy out minus our enthalpy in, or enthalpy of the exterior minus the enthalpy of the interior, rather. For this, it allows for the calculated amount of heat transfer or the energy exchange across the fluids. Here's an example problem. We're going to consider a water-cooled condenser with our refrigerator with refrigerant R134A. Refrigerant enters at 1 megapascal and 333 Kelvin at 0.2 kilograms per second, which is our mass flow rate, and it leaves at 0.95 megapascals, 308 Kelvin. So we're going to try to find that heat transfer. But by the equation from the previous page, we can just go to our thermodynamic tables, and it's a quick, easy plug and chug method of finding what's our heat transfer from the refrigerant to the water, and we find that was 38.55 kilowatts. And here's some common uses for heat exchangers. They're used extensively in power plants, steam generators, condensers. They're used in vehicles, to whether they cool the engine or they're used for your air conditioning unit. Speaking of air conditioning unit, basically a refrigerator, which is the example from the previous slide. The summary of this is, heat exchangers transfer heat, obviously, from one source to another. The first law of thermodynamics is a governing equation to help solve for that heat transfer and how much of it is transferred. And as you can see from the previous slide, it's used in many concepts: daily life, refrigerator, vehicles, everything. That is my reference. Any questions?